This time on Jairus of All, guess what's back? Mantis Blades. At the end of the last video, I unintentionally lied because I thought that the blade was completely finished, but it wasn't, because in order for the blade to be completely done, it needed to have the carriage adapter installed. And the carriage adapter, I couldn't finally design until I knew the design of the blade carriage. So I had to design the carriage so that I could design the adapter so that I could install it on the blade. The carriage is a very fiddly handmade part that has to be very accurate, that is made up of 6 parts in the main section, and once it's entirely assembled, it's made up of over 22 parts, with ratchets and pawls and washers and slide rollers and ball bearings and set screws and retainer screws. It's very complicated, and I can't show you how it's assembled and installed until I have the carriage plate adapter installed on the knife. This is the carriage plate adapter that allows the carriage to be connected to the knife. And this needed to be put on, and the best way I could think to do that would be to plug weld it from the inside onto the outer plates of the knife. The difficult part is, if those rods are not perfectly aligned from side to side, it's gonna go all over the place when it moves and it won't work. So this is actually a very difficult step in getting this thing put together.
3 weeks earlier.
I did tests on metal plates to see what settings would work best for doing these plug welds through one sheet onto another one, and it seemed to work really well when I set the machine up to weld through 3/16 inch thick steel. This is 16 gauge. Let's hope I don't blow through it like crazy. I gotta get a couple welds on the front before I can do the back. That sounded like a garbage weld. It's attached. Just cool it down a little bit. This is my portable fan. It's very conveniently sized. Very little warping. So far, so good. Sometimes you gotta live dangerous. I'm welding the ones closest to the bolts all at once because then I can carry the heat through to the next spot and most likely get a much better weld, even though I have the heat cranked like crazy anyway. Here we go. Once the carriage adapter was welded to the outer plate of the knife sheath, it had caused a tiny bit of warping. And after I had the welds ground back, I assembled it, and I didn't think it would matter because such a thin plate bolted to such thick plates of steel I figured would make everything flat again. But it didn't, because the knife wouldn't move at all. So after I coated everything on the inside with blue Dykem and forced the blade back and forth multiple times of assembly and disassembly and finding the interference points and grinding them back, I got the blade to move, but it was still binding. So I had a solution that I didn't really want to do, because the idea was to make really tiny micro ball bearings by hand for the blade to roll on. This is a deep groove ball bearing. It has an inner ring and an outer ring that's separated by balls that roll, and it seems like it would be difficult to take this apart, but it's actually pretty easy. And it's the exact same system that's in this little tiny one. And I need to take this apart, and I'm gonna show you how to do it because I need its balls. The first step is removing the shield. It's this big black plastic part on the large ball bearing. On this one, it's a little tiny metal piece, but if you can get something sharp in there and pop it out, you have access to the cage that holds the bearings in their places. Some cages snap in and you can just push them out, but this has little tabs that fold over to hold the two sides of the cage together, and you just pry the tabs apart and you can push the cages out. Once the tabs are out of the way, you can lift out and hopefully let go of the cages. With the cages removed, the balls can move out of location, and if you push them around until they're all touching each other, the inner race will pop to the side, and then you can dump everything out that was inside. And now I have my balls. These are installed on the blade now, but instead of disassembling everything to show you the actual ones on the blade, which are too small to film and really explain, I'm gonna draw you a picture of what I did. The back of the titanium blade is square. So there's 4 points where I wanted to put bearings. So at each of the 4 corners at the back, I wanted to drill a hole across the section of titanium that was 2.75 millimeters thick, which this is Delrin filament. It's supposed to be 285, but it's actually 2.75. But I can't drill those holes because they actually have to extend out beyond the surface of the titanium. So I had to use a tiny little carbide burr bit to grind that hole in perfectly round at the right size so that this Delrin filament could friction fit. And then I trimmed little tiny pieces of it to 3 millimeters because that's the thickness of the titanium blade. And that's what would friction fit inside. And after those were ready, then I had to drill a hole down into that tiny piece of filament at 2.35 millimeters because that was the size of my itty bitty balls that went inside the itty bitty piece of filament. I had 0.2 of a millimeter of margin of error on each side when making that hole. Needless to say, I made a lot of these before I got 4 of them that actually worked. And that would give me a little cup so that whenever I pop this down in, I could slide that in from the side and I would have a little bit of the ball sticking out of the top. That way I'd have a self-lubricated roller ball bearing installed in the blade at all 4 corners. And then the blade rolls in and out instead of having to slide. I should be able to put this all together and show you how the carriage goes on, but there was still one more problem that I hadn't worked out yet. I did a bunch of tests with different lubricants to see what would not mess up my elastic retract for the blade to come back in, and all of them expanded the rubber. And when that was happening, when it was put together, it would make the elastic cord longer, and then it wouldn't pull on the blade as much, and it wouldn't retract. But installing those ball bearings on the blade made it move so easy that I don't have to use nearly as much lubricant on the inside, which means it's not going to get all over the retract cord. I don't have to solve that problem. It just solved itself. And it's silver now because I didn't like the cold blue that I did on the surface, so I polished it back and polished a false edge onto it. The main carriage piece is what moves the whole blade section up and down, but it does not rotate the blade independently. The blade carriage adapter does that. So in order to assemble this, the ratchet part gets installed on the bolt that is piece of the adapter plate. After that is put in on the back side of the carriage, a retract cord with the pawl for that ratchet is installed in my handmade socket thingamajig. There's an itty bitty hole that is drilled out to fit the seat spring on the bottom of the pawl. And then there's this high strength cord that goes up through the center of that spring and is attached at the top. And that hole was peened over so that the spring can't come out the bottom, but the string can, and it gives me my engagement. As long as that's retracted, the blade can move around freely. But once it's extended, it can move forward, but it can't move backwards. This isolates the force of cutting watermelons in half with this from the servo. Instead of all of that force going back the movement mechanism into the servo, it transfers it into this big steel carriage piece and into the big movement arms for the rest of the rig. So now this can be installed on top of the ratchets. But to transfer the movement into the carriage adapter plate, to move the knife blade independent from the carriage, we need a control plate, which has a hole drilled and tapped for a set screw that I made, and that fits on the outside and keeps that section locked in place. On the arm mount points, I also needed bearings for where the arms connect, and then those bearings where the arms connect will have on the outside of them a washer, one slip ring, another washer, another handmade slip ring, followed by another washer, and then that gets a retainer nut to hold it all in place. The front connection just gets a washer and a retainer nut because I haven't figured out exactly where these release cords are gonna go. So this might have a slip ring on it too, where that goes around and goes down the movement arm. Then there's a keeper plate and retainer screw that is installed into a hole that I drilled and tapped in the center of the main bolt that holds it all to the knife. The bolt was trimmed to a very, very exact length so that when this is tightened down, everything is held right in place the way it's supposed to be, and there isn't any slop for it to move around. Now this moves, but if I release the latch, it can go forward, not the other direction, because it locks up on the ratchet. But if I pull that, it can go that direction. So with both of them set, I need to make a link plate between the two to keep them lined up so that the movement is synchronized. These stay in place, the blade can move back, and then it can swing forward to attack. And then when I want it to move back, that string will be pulled by servo, and it will unlock this system, and the little carriage piece can go back to where it wants, or it can let this move way up high. And if you imagine this connected to arms at the end, you see it's vertical, so I can stretch back like that, because this is standard, staying at one spot, and then when I swing forward, it can ratchet forward, so it goes shoo, and will swing at the same time like it does in the game. Remember that whole intention to make this thing function exactly like it did in the game? Never should have said that. But I did, so here we are. And I got the system complete for it. Does it make sense now? Do you understand why I hate this project so much? But the project continues, and now I can install the movement arms, like I said last time, and connect this to the carbon fiber frame that goes on my arm, and start installing electronics on it to make all this move around automated. Our intention for this video was to have the project to the point where this was installed on arms on the carbon fiber frame to show you how much progress I had made on the project. And you know how long it's been since the last Mantis Blade video, and I don't want that to happen again. So from here on, we're gonna release a video a week on this project, no matter how much progress is made. But I feel like you guys deserve to see the problems that I run into in trying to complete this project with trying to do something this complicated with the tools that I have on hand. Click on the buttons if you want to help out, and I will see you guys next time when I continue the most ridiculous and awful project that I have ever taken on this channel. But it also is about to get really cool. Thanks for watching. See ya.